Hi, Michael.
Good morning.
Morning.
Are you in Silicon Valley?
No, not this week. I uh I think that I'll be there somewhere in September.
Good.
Yeah,
Good for you.
right. We have an office in San Jose now, so I would usually um now there's more frequently gonna travel there at the
Good to hear.
Ironman.
Good morning. Can you hear me?
Yeah, I can hear
Yeah.
you.
Okay, good, good.
How was the talk on Tuesday? I think I miss your talk. I was in the early one, but then afternoon I kind of switched channel to the hot chip.
Yeah, yeah. It went well, I think. Didn't
Uh-huh.
get too many questions. So
This was a
my
this was a
talk cut
talk at what venue?
the OCP AI workshop. This one is on part/cluster interconnect.
Yeah, I missed that.
Yeah, but my talk is actually sticking out a little bit like a sore thumb. I talk mostly copper, a lot less about networking and some other angle of the AI network. But that's okay. Yeah, I did get a request after the meeting, so I suppose it's good then.
Yeah, that's great.
Yeah.
Hi, Samek.
Good morning.
Raymond, are you based in Silicon Valley?
No, I'm actually in Oregon,
Oh, you're in
Portland
Oregon.
area.
Okay, I see. So let's give people a few more minutes to join in. I don't know if it's gonna be a I don't know if it's gonna be a lot of people joining today or not because I think I forgot to send out a reminder. And also it's a it's a day before the uh, Labor Day's long vacation, so I guess many people is already gone uh to take the tail of the summer. Hi, Daryl.
Hey, good morning.
So hopefully my note uh, was behaving like a reminder.
Yeah. Yeah, I saw you send out the target parameters and I think that's yeah, that's a great things for reminding people. Um, it's good.
Yeah, but basically that is what people are asking, all the customers, and saying, hey, first do no harm. Remember, I'm already used to certain things.
Hmm.
You're giving me something that's lovely, but don't take me back.
That's great. All right. Okay. So um I think we have a couple more people join in today. It's going to be a small, looks like it's going to be a small group today, probably due to the vacations. Um, and um, and I'm glad that Sumaki helped send out the an email about the target parameter, and think uh, I uh, I have a Karen's voluntary working on the chapters, which is section 3, and those are the key metrics that I think key metrics that she will addressing all these stuff. But I'm glad you will be able to chat with her about offline about all these parameters. Karen and I had a conversation yesterday to kind of go over the things a little bit, and I think the idea was helping helping people or the network architect, like you said, like you said, it was people are asking about it, so we can clear it out all these key metrics, and key metrics, and then in the next sessions we will have the the parameters for each technology. Then
Have we in this forum talked about the numbers for these parameters, not just the existence of them, but the number ranges for different technologies, different techniques? Or do people think that these things are proprietary, don't want to share? Because
I think we had um we had I think where is that use case? We had this table before, so we kind of working was this a while ago. We said these grayed out, the gray out columns that we probably don't want to address it in this group anymore, because these are probably some very special cases. And then I think after a while we start saying that we're gonna go to go over the scale up network things. And I think in here there's it's probably more close to these cases in here, and then we have these parameter in here, and I think like you mentioned it in your emails, there a lot of things are tangling together, and I think that is probably the places that we can clear out a bit in our white paper, and help people to pick the technology in the future. So this was to table, and in one more things was when I talked, I sent an email.
I'm sorry, Bobby, before we move off of the table,
Yeah.
I totally appreciate that some of these parameters might be a function of distance, for example, or other things. So maybe we can create a method for people to plug in a chart instead of a number for the cells in the table. For example, bit error rate, it might be a function of the technology used, whatever. So that might be a table within a table. If there is a time of flight, that might be a function of the number of meters of fiber. The power might be a function of, again, either the technology or distance or something else, or bit rate. That could be a small table or small graph, so that it is in fact useful. Or we can come up with, as part of use cases, we can say, hey, our use case within a chassis, so the distances are less than 50 centimeters, or it is within a rack, distances are within 2 meters, across racks, maybe less than 5 meters, and then have a name for these use cases, and then people can respond with those parameters, with those numbers.
Yeah, that's a good idea. Let me find a place to write all those things down. I was then 100% sure how to, how to create that into a chart or a graph with that, because if we mainly focusing on the scale up network, is there a specific range that we should be more focusing on, and especially these scale up network, they probably have a switch, one level switch or 2-level switch somewhere, and then they're gonna connect it to each pod or something together.
The ambition for us short reach optical people might be that we have enough parameters and numbers, even when other people think they're going to use copper, to just tell them, if instead of copper you use optics, these are the value you get. Therefore, I'm not shy about even mentioning things within a chassis. It is still within the scope of scale up network, but that scale up network from a device, an XPU, reaching the first layer of switches, could be inside a chassis. But the reason you use optics not is because it is good for distance in that model. In my opinion, you use optics because it is small structure and it can have many connections in a small space, shoreline density and port count and other things. That's why you would use itsy bitsy little tiny fibers instead of big thick cables. So therefore, our parameter and our table should include smaller distances too. And I'm thinking maybe 50 centimeters is good enough. You're starting with the middle of the chassis, some super chip, something in the middle, and you want to reach the edge of the chassis because there is a switch maybe there or another device there to distribute outside of the chassis. And then so the inter-switch interconnect could be within a rack, and then something outside of a rack within 5 racks, for example.
Sounds good. But is it possible that maybe you can just create a maybe a scratch of this kind of drawing, that I don't know if put down the merit or something that people can think of, then we can talk with Karen about this, and we can also share it in the email.
Okay, yeah, I'll try to capture these, and I'll call them maybe use cases, to match your terminology here.
Hi,
Yeah,
Bob.
I think this is great.
Hi, Bobby CMAC. Sorry, I just.
Hi, Karen.
Hello, Karen. Were you there when I was explaining this?
No, unfortunately not, but I guess it's recorded, so I should be able to get this, Bobby.
Let me
Yeah,
repeat it in a quick way. That helps me then
That would be great.
formulate the way I would capture it. Bobby asked me. So I was wondering if we could, since these parameters are a function of other factors, having a simple table and a number doesn't do justice. So maybe we can create a table thinking that we would have a number, but in a case that we don't have a number, we refer people to a chart below or actually insert the chart inside of a table saying that, hey, this particular parameter is a function of distance or number of ports or the amount of heat or temperature or whatever that is.
Right, right. The dependence. Yeah, yeah.
But then Bobby asked, well, what ranges, what use cases should we cover? And in response to that, I just wanted to maybe bring all of us back to the point that we're talking about many aspects of photonics being good. Bit error rate is good, power is good, bit rate itself is good, distance is good. All of those things are good. But the one that I really like is the fact that we can pack a lot of things in small spaces. Many ports at a beachfront shoreline, and the fact that they can go point to point to many different things. Therefore, I'm not shy in saying, hey, why don't we have a choice for people to use these things in small distances? Small distances within a chassis. You're in the middle of a chassis and you want to reach the edge because the component you want to reach, the switch or retimer or something, is at the edge of that chassis. And therefore, things within 50 centimeters might be just fair. And then you go outside of the chassis, a blade, a compute blade connected to another switch, or therefore there's maybe a switch inter-switch link could be within a rack. So that's 2 meters, 3 meters. And then you go from rack to rack within 5 racks, 10 racks. So that is maybe 10 meters or 15 meters or so. And then you go to your other numbers that you're used to, many meters. So these could be different use cases. Did I capture it right, Bobby, this time?
well, I think it's, yeah, I think what you shared is it's good. There's no absolutely right or wrong. I think it's, we'll try to come out with a good way to tell the story.
I have a question on the concept of use cases. I mean, in the original table as shown, we have XPU to memory, which we're, I think, no longer addressing. But we separated XPU to XPU and XPU to IO. Are we still using this separation? And it's unclear to me what IO means in this context. I mean, all of these are IO, strictly speaking. They're going from one thing, out one thing and into another. Are you talking about switch as IO here, as opposed to direct XPU to XPU? Does anyone remember how we had conceived of this?
I don't know how you arrive at this, but the word IO is very vague here.
It's
And
all IO, right?
even the word XPU is very vague. And I don't know why we would differentiate an XPU to XPU from an XPU to somebody might call it a memory device or memory appliance. These are all point-to-point interconnects. So if you have an optical engine on one side, an optical engine on the other side, well, to us, short reach optic people, why does it matter what's in it? Is the point-to-point link is defined by 2 ports, one on this side, one on that side, and stuff in the middle.
Yeah, hey, so Mike and Bobby and Karen, this chart is old, and I think the real thought process when we put this chart together, maybe, gosh, it was a probably close to a year ago, was on the protocols, right? So we said, okay, what protocols are we thinking of supporting, and then bandwidth per interface, and that's where you said, okay. When we thought about PCI Express, okay, that was more of an IO interface versus UA Link was a XPU to XPU. I'm fine to just completely drop that terminology, but I think in our white paper we want to, you know, part of the challenge here is like defining the metrics for short reach optics. Part of that needs to be protocol, and it needs to have all of these, like these are the parameters that we need to clearly define, so that if a vendor were to develop a product and it meets these metrics, that it could be successful. So that's where this came from, is trying to define the
Thanks for the
metrics.
reminder. Yeah, thanks for the reminder that here it was protocol centric, which is no longer our approach. Okay.
Right, exactly. So I mean, I'm fine to drop it, but I think let's make sure we capture the metrics in maybe a different table format.
Yeah, I think it's, when we had this table, there's no clear define of the scale up network, I believe. And I think now we have the UA link spec, we have SUE spec. Looks like there's no directly XPU to XPU connection. I think one of the things that we thought before was something like um, a, 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 a pod inside that has a GPU or accelerator that could talk to each other. So that's why uh, we have all these direct die to die or XPU to XPU connection. Then we also add something like, oh, maybe there's a one layer switch or something. That's why there's to IO, but looks like people are all these scaled up network add at least a layer of switch in their protocol.
I've thought about a number of different topologies that may benefit from stretched copper or photonics. And sometimes the choice might not be because can I do it with copper? It might start with, hey, do I want to have a device, maybe build a switch or some XPU or memory appliance device that wants to be flexible in small spaces or long distances or any of that. Therefore, I put an optical engine on it, and then it's very flexible. And you want to put it inside the chassis, that's fine. I don't care. But then what type of technology should we use for that? And I don't know, you guys are the optical experts. If I design such a thing, but I want to use it for a much longer distance, do I even need to change my optical engine, or can I use the same thing in a bigger range with different parameters? So you tune my optical engine to just go farther and change the power envelope or bit error rate, but just say I can still work. These are the flexibility you give the system architects.
Yeah, so I think that falls under your concept that you would say that something is a parameter of something else, right? Like you're saying reach might be a parameter where power would be linked to it. Yeah, that makes sense.
Yeah, so certain things need to be done by design, by manufacturing time. Some other things can be changed at reset time or installation time. So you might say, I build this optical engine chiplet, you put it in a package, now it is fixed in space, but I can tune it for short distance and I give you this bit error rate and this much power or energy efficiency. You want to put it in a rack-to-rack installation, then I give you a different parameter. The same device, same package, maybe even the same cable, but parameters are different.
Hey, see, Mac, as an architect, I wanted to ask you if you agree with the simplification that Bobby was mentioning, that we would assume most architectures would go from XPU to switch,
No,
scale up,
no.
as opposed to direct. So we maybe do need to have these two cases where one is direct and the other is through a switch. I don't know if that would change any of the parameters, but
Exactly. That's what I'm trying to ask the experts here. Why should it matter to us, short reach optic people, if the end device is a memory or XPU or a switch? Some people want to build these things, might want to project the usefulness and therefore volume sales. Those guys care if they, which market they sell to. But for technical, physical, optical aspects of it, does it in fact matter?
I guess I would throw it back to you and ask from the chip side rather than the optical side. Do you think if one end of the connection is, say, at an XPU, whether it's co-located with many other XPUs or not, would that change things? And the other end, say, is at a large switch, right, where you've maximized radix, say. Would the requirements for those two ends of the links require different densities, for example, or different power envelopes, do you think?
So I think hierarchically it starts with the use cases. You guys have identified that very carefully. If I want to go inter-switch links, in the past I've called those things maybe fat pipes. You have aggregated a lot of bandwidth in small space, and you want to go maybe long distance. Switch to switch, maybe L1 to L2 switch or L2 to L2 switch. There are fat pipes. But when at the device level, a lot of diagrams I show these days, because photonics gives me the tininess of structures and the fibers, gives me the hope that we can have many ports supported by a device. How do I do many ports? Well, I need to have the right chiplet. Okay, the next question people ask, what use case are you covering? Which bit rate do I need to do? How many ports do I need to have? For that, I have to tell them, the aggregate bandwidth for this port, this not just port chiplet, is 1 terabytes per second or 2 terabytes per second or whatever. And they say, oh, okay, so I need so many ports at this bit rate and this wavelength or this whatever. And since there are more than just one, then I, as an architect, can split it. And although the aggregate is 2 terabytes per second, 1 terabyte per second, I can go to 10 places, 16 places, 32 places. So that's the way I normally think about these things. Now, what protocol runs on this, if it is PCIe or UA link or whatever, I have to choose that because it needs to match my underlying, the bigger use case. Is it an AI ML? Is it database? Is it, anyway, so. Now, the questions about, is it a switch or is it a memory controller or is it a CPU or whatever, those are some other platform choices and maybe manufacturing choices, because you want to build something that goes everywhere. if I'm a chiplet designer, I need to have an interface to the electronics sides of the die. If it is UCIe, then I put it wherever UCIe is welcome. Could be an XPU, certain XPUs, not all of them. Could be memory device that will be done in the future. Okay, in that case, because chiplet is UCIe, they should do UCIe. The opposite is also true. If we know exactly what we want and we already have a customer, we don't need to be working in the open. We're just working NDA under a different environment, and those guys are working. You guys are already working with your customers. When we talk about here, we're talking about somewhat general purpose, somewhat pervasive, hopefully. And therefore, we should not be very choosy. Otherwise, the volume goes down and things become very expensive.
I think, Sean, what you just mentioned about it was exactly the topics that I shared a little bit earlier, which is the was our the committees that the Cliff there has mentioned that maybe in our white paper we can talk about what OCP what's short-reach optics we're working on in the future, and then after we graduated from the FTS, and then we can if we successfully graduate, we can go into the work stream and build it up some open spec that could benefit the whole OCP community. And I think what you just mentioned it, for example, build something that can work everywhere. That could be one of the key requirements for the future, or I think there should be some envelope, especially for this kind of scale up, for example, the potential distance, the potential the power energy efficiency, how good that has to be. Anything has to be below that, or something like has to be the reliability has to be reached to a certain point in order to be competitive, or even something like the cost has to be reached to a certain point. And I think that would be a fantastic things that we can conclude that, put it into the very last session and talking about it. That just something crossed my mind. And I know we reached the time, and I would like to everyone to share some thoughts about it. Don't hesitate to bring your thoughts. We're still working on it, so anything is our welcome. And I hope there's a more active offline activities, and then we can talk about it next time.
May I ask the team to offer parameters for a very simple table, something like energy efficiency, bit error rate, maximum bit rate, things for the technology that you care about. Say, I'm designing this for these parameters myself. If you're already advertising that in public for customers or whatever, let's just have at least start with that, whatever it is, whatever it will be in the future. That might take a lot of discussions to craft that table.
Great. Yeah, I think we might have some that number already, but we can, certainly if people would like to provide, please share it in in the email threads or anything else.
I just want to highlight that some people might feel uncomfortable sharing this in the public, but at the same time, you have to share these things with your customers, and your customers are going to ask your competitors anyway, so they already know everything. The customers who care, they already know. So just, I don't know, just food for thought.
Thank you, Sam. Yeah. So, thank you everyone for your time, and enjoy the long weekend vacation. And we'll see you next week. Bye.